Okay, so I'm only going to do a few problems on this one because you should already know how to do the rest of them. This is problem number 3 on the sheet. I'm going to do 3, 4, and 5. So problem number 3 says a particular bacteria population on an athlete's foot doubles every 4 days. Doubles, that means every 4 days is going to multiply by 2. Determine the expression for the number of bacteria in after t days, given the initial amount of 50. So we started with 50. Let's make a table of what that means. If I started with 50, right, then that means 0, 50. Doubles every 4 days. That means in 4 days, this number is going to double. El doble. 2 times. So 50 times 2 is 100. That's double. Esto es el doble. Another 4 days. That's 8 days. It's going to double from 100. So 100 times 2 is 200. So what's happening on the left side? You're adding 4. Every time you're adding 4. Okay? Every 4 days. So the next one would be 12, right? What's happening on the right side? You're multiplying by 2. Multiply by 2. And I can put parentheses instead. Multiply by 2, multiply by 2. So to get the next one, we're going to multiply by 2 again. That's going to give me 400. Okay? So then you're going to put the answer choices, all of these answers, put in y equals, second graph, and see which one gives you this table. Okay? That's how you're going to find the answer. Problem number 4 is very similar, but I have to do it because of the words that they're using, the wording. It says the population of a swarm killer bee multiplies tenfold every 50 days. That means multiplies by 10. Tenfold. It's going to multiply by 10 every 50 days. So let's make our table. It says that the initial swarm had 1,000 bees. So at 0, I start with 1,000. So what do I do over here? You're going to add 50. What do you do over here? You're going to multiply by 10. So if I add 50 here, now I have 50 days later. And if I multiply 1,000 by 10, you just add a 0. It's 10,000. Okay? And you continue. You add another 50, and you multiply this one by 10 now. So 50 plus 50 is 100 days later. Multiply 10,000 by 10, now it's 100,000. Okay? Then you're going to put these answer choices, put them all in y equals, second graph, and see which one gives you this table. Okay? Problem number 5. We're going to have to make a table. Where is it, right? This is 6. This is problem number 5. Edna is inflating balloons for a graduation party. The balloons are 12 inches in diameter and are full at 0.54 cubic feet. That's when they get full. That's when they fill up. Use a table to determine how long it will take to blow up a balloon versus using a helium tank. Different rates in feet, cubic feet per second are approximated by the functions below. So if we blow it up, this is the equation. Y equals, parentheses, x over 10 to the power of 3. And if we use helium, okay, that's y equals 1/2, which is going to have to be in parentheses, 1.1 to the power of 0.3x. Okay, so those are my two equations. We're going to put them in y equals and second graph to fill in the table. So I'm going to go one at a time. Or should we put both of them in at the same time? Let's put both of them in at the same time. Go to y equals. The first equation, parentheses x divided by 10, close parentheses, to the power of 3. Okay. And then the next one is 1/2 in parentheses, because it's a fraction. Parentheses again, 1.1 to the power of, remember this is to the power of, this little caret sign. Mine looks different than yours, but it does the same thing. To the power of 0.3x, close parentheses. Second graph. Okay, so we have to put all of these points on the table. So go ahead and start writing them. Write all of these down and go all the way to 10. So we're actually starting at 1. So right here. Write this one down, write this one down, write this one down, write this one down, like that. All the way to 10. And then on the other side, same thing here. We're going to start with this one. And if you want to, you can round. It doesn't have to be exact. Write them all down. Go ahead and pause, write them down, and then I'll be writing them down at the same time, just to make sure we're all on the same page. Okay, so at 0, my red. I got 0.001, 0.008, 0.027, 0.064, 0.125, 0.216, 0.343, 0.512, 0.729, and 1. Let's make sure that that's what we got. Yep, that's it. Okay, on the next table, and make sure that when you hold on, let me erase these. Make sure that when you put this equation in y equals, that you put this in parentheses, because maybe you might not be getting the same numbers that I got on here. Remember, you have to start with 0.5145. So if you didn't start with these numbers, if you didn't get these numbers on your table, then you need to fix it on your calculator and make sure that it has those parentheses, okay, so that it works. So the numbers that you get here are 0.515, 0.529, 0.545, I'm rounding, 0.561, 0.577, 0.593, 0.611, 0.629, 0.647, and 0.666. So I highlighted this one over here. I highlighted these two because that's when the balloon gets full. Remember, it has to be full at 0.54 cubic feet. These two are between 0.54 cubic feet. So on this side, which two are between 0.54 cubic feet? So that would be between 2 and 3. So the answer would be D. you're going to do the same thing like this for problem number 6. So again, if you got confused, it was probably with this equation, so make sure that you put parentheses around your exponent, because this is how you're going to be writing it. You're going to put parentheses 1 divided by 2, then parentheses 1.1 to the power of, and you need it in parentheses, 0.3x, close parentheses, and close it again. Okay, so that's probably where you messed up. Make sure that you fix that.